Hello everybody. We are discussing today the topic from physics, elasticity. I am Srinivasa Charyulu. Elasticity is one particular chapter at Eamcet level. Every year we used to get one question from that, which of course is a very simple one. Truly speaking, a body, when we are just applying some force and deforming the shape of the body, then after the relaxation of the deformation forces applied on the body, if the body comes back to its original shape, then we can call the body as an elastic body. And the property of the body is said to be elasticity. We in fact know this point well. The opposite term to elasticity is plasticity as such. And the body which is having plasticity as its property is to be called a plastic body as such. Elasticity is mainly based on one major equation that actually is called Hooke's law. When we consider this, within the elastic limit, stress is directly proportional to strain. Stress, in other words, we can say force per unit area. Strain, in other words, of course, we people used to take it as change in length by original length. That of course three different stresses we have and three different strains we have. Thereby we can write modulus of elasticity as simply stress divided by strain. This actually is the basic equation. While talking about modulus of elasticity, we discuss three different moduli of elasticity, namely Young's modulus, bulk modulus and rigidity modulus. Generally, we represent this one by eta. In some of the cases, it looks like n also. So, whatever be the letter that fellow is using over there, it is immaterial for us. We can take that as modulus of rigidity or rigidity modulus as such. So, if you talk about Young's modulus, force per unit area, that is called longitudinal stress by linear strain, elongation per original length. In other words, FL by AE. This is the way we people used to represent this Y. Exactly like that, when we talk about bulk modulus, it is the pressure applied by the change in volume. What is going to be this change in volume by original volume called? It is called volume strain or bulk strain for that matter. And of course, you all know very well reciprocal of bulk modulus, we call it as compressibility. That also is one of the important most theoretical points one should remember over here. Likewise, when we talk about rigidity modulus as such, eta is equal to force per unit area by that is angle of shear that is produced in the body. That of course, when you are applying some force to twist a particular body, whatever the angle of shear that has been produced, that itself we call it as shearing strain. So, F by A by theta, that now gives you rigidity modulus of the material. But one thing you can understand, this even can be rewritten as force per unit area divided by displacement by breadth of the body. What do you mean by this concept of displacement by breadth of the body? Suppose when I consider a body this way, keeping the base constant, if I directly apply some force on that one on the topmost layer of it, then automatically this point D and this point C are now going to be displaced to D dash and C dash respectively. Then this displacement, if I take it as x and this value is considered as breadth like, then if I consider this as theta, when theta is small, tan theta can be written as theta. We know that one well. This tan theta now can be taken as x by b. So, in place of theta, x by b also we people can write. So, more about elasticity when we discuss. Naturally, Young's modulus, bulk modulus and modulus of rigidity are the three major moduli of elasticity one should remember. And in addition to that, there is one more ratio which of course we call that one as Poisson's ratio. If you take this Poisson's ratio, it is nothing other than lateral strain divided by longitudinal strain. That in other words, you can write delta R by R divided by delta L by L. This in fact we represent that one by sigma. All of you should understand what is delta R by R. Change in radius by original radius of cross section of the body. That in other words, we can call this one as a lateral strain. By longitudinal strain, since these two they vary in opposite way, we people used to predict a negative sign over there. And we know pretty well the values of sigma, they vary from -1 to 0.5 theoretically, 0 to 0.5 practically. And for metals, the value of sigma that varies between 0.2 and 0.4 as such. Likewise, of course, 9 by y is equal to 3 by n plus 1 by k. In fact, this is the relationship between Young's modulus, bulk modulus and modulus of rigidity. These are the basic formulae one should remember before entering into this particular chapter called elasticity. One question surely we will be getting at Eamcet, I have told you. So, let us work out few model questions based on this particular chapter elasticity. Let us see the very first number please. A 20 kg load is suspended by a wire of cross-sectional area 0.4 millimeter square. The stress produced in Newton per meter square is how much? That is the concept. In fact, we can understand well stress produced, that is what is asked. Stress is nothing other than force per unit area, same as that of pressure. Both stress and pressure have got the same dimensional formula, ml inverse T power minus 2. They both have the same units, Newton per meter square as such. So, if you take up this one over here, what is the force that is given there? 20 kg is the load. Force now can be written as mg and A is area of cross section. Now you can take directly 20 times. What is the value over here? G is 9.8 by area of cross section is given 0.4 millimeter square. Millimeter square to be converted into meter square means you should write 10 power minus 6. This point and this point you can cut them off. And of course, you can write directly this 4 goes 5 times. So, it is now 490 into 10 power 6. In other words, you can write 49 into 10 to the power 7. Of course, according to the values given over here, what is the correct option here? 49 into 10 power 7 you can write. Otherwise, you can write 4.9 into 10 to the power 8 Newton per meter square is the correct option there. That means the second option which is going to be true for this is directly based on the basic equation for stress which is nothing other than force per unit area. Let us now check the second number please. Problem number 2 in this case. The length of a wire under stress changes by 0.01%. The strain produced in it is how much? One should understand 0.01% mathematically means 0.01 by 100. You definitely can understand it is nothing other than delta L by L. This becomes change in length. This becomes original length like 0.01% means is it not simply 10 to the power minus 4 please? So, of course, you should understand now the strain produced in this particular case is going to be 10 to the power minus 4. So, that means the very first option is going to be the correct option for it. But remember carefully, strain being a ratio of lengths or volumes, whatever you talk about, strain has no units. So, no unit needed to be predicted for this one. 10 power minus 4 simply is going to be the strain produced in the wire as such. Now, let us come to the next number, that is problem number 3, whatever we are having. The lengths of two wires of the same material and diameter are 100 centimeter and 125 centimeter respectively. When a force F is applied, the elongation in the first wire is 4 millimeter. When the same force is applied on the second wire, its elongation would be how much? That is the concept. In fact, we all know Young's modulus formula when you take up, elongation can be written as FL by AY. Observe carefully, F is the force that is applied. L is the original length of the string or the wire, and A is area of cross section, Y being the corresponding Young's modulus. Now look at the wording carefully. The lengths of two wires of same material. Same material means what? Their Young's modulus is going to be constant. That is one zone you have to understand. And diameter also. Diameter is same means areas of cross section are going to be equal. You can definitely understand even that point also. When a force F is applied, that means the force is a variable you can think of. It is elongated by 4 millimeter. Which one? The first one. When the same force is applied on the second wire, that means force also is going to be constant over here. So what we should understand here now? E is proportional to L. That is the concept. So what to write here? E1 by E2 is equal to L1 by L2. Now E1 is given 4 mm. E2 is to be calculated. L1 is given 100 centimeter. L2 is given 125 centimeter. 4 times 25 here, 5 times 25 here. Numerator gets cancelled on both sides. Then what will be the value of E2? This now will be 5. What? Whatever the unit for 4 that has been given in the problem, that is millimeter. 5 millimeter must now be the corresponding elongation produced in the second wire as such. So the correct option for this question is the second option, that is 5 millimeter. Let us check the next number, that is problem number 4 as such. A solid sphere hung at the lower end of a wire is suspended from a fixed point so as to give an elongation of 0.4 mm. When the sphere is replaced by another one made of same material but twice the radius, the new elongation will be how much? That is the concept. One should now understand carefully here. Elongation no doubt is going to be FL by AY. That is the general formula. Fine. When the sphere is replaced by another one, that means what? To the same wire, sphere is going to be changed, that's all. Wire has not been changed here. So what you should understand here? The original length of the wire will be the same, and the area of cross section of the wire also will be the same, and we know very well the value of Y also is going to be the same. That means he is talking about a solid sphere. Then can't you just understand force now becomes weight, please? Elongation when the sphere is replaced by another one made of same material but twice the radius, that is the concept, right? If you look at the first part of it, solid sphere hung at the lower end of the wire is suspended from a fixed point so as to give an elongation of 0.4 millimeter. That is the concept. Now look at carefully. You can write mass is equal to 4 by 3 pi r cube into the density rho. So what can you write from this one? Mass is proportional to r cube. Then what you can write now? E1 by E2 is equal to r1 cube by r2 cube. Given in the problem that radius is doubled, then automatically you can write this one r1 cube, and this one will be 8 r1 cube because r2 is equal to 2 r1. This now gets cancelled. Then what will be elongation 2? It will now be 8 times the first elongation. What is the first elongation given? 4. The 2.4 given. So 8 into 0.4, which now becomes 3.2 millimeter. That is going to be the corresponding elongation produced. That means which option is correct over here now? The third option is the correct option for this particular question number 4. 3.2 millimeter as such. Now let us check the next number, please. Problem number 5. Two steel wires have equal volume. Their diameters are in the ratio 2:1. When same force is applied on them, the elongation produced will be in the ratio of how much? That is the concept. Now one thing you should understand, wire is nothing other than a cylindrical body. It is going to have circular cross section and length as well. Therefore, pi r1 square L1 is equal to pi r2 square L2. This is the meaning of saying their volumes are equal. Pi r square base area into height is going to be the volume of that cylinder as such. Now what can we write from this one? L1 by L2 is equal to r2 square by r1 square. This is the relation you can arrive at by looking to these two values equated to one another. Now the elongation produced will be in the ratio of, is the question, elongation E1 by E2. It is now depending on the ratio of their initial lengths and inverse ratio of their squares of the radii of curvature, because elongation is proportional to L and inversely proportional to area of cross section. Area of cross section is nothing other than pi r square. So L1 by L2 into R2 square by R1 square. But what is L1 by L2 again? R2 square by R1 square into R2 square by R1 square. That in the sense, what are you going to get from this one? It is now R2 to the power 4 by R1 to the power 4. That is going to be the corresponding ratio of elongation. What is R1 is to R2 given in the problem? 2 is to 1. Then R2 will be 1 and R1 will be 2. Come on, 1 to the power 4 is 1. 2 to the power 4 is 16. Then what should be the corresponding ratio now? 1 is to 16. Look at the options now please. The very third option is saying 1 is to 16. But you should not have any sort of a confusion in this regard, because fourth option is given 16 is to 1. We are just taking the orderliness in the same manner. Therefore, it should be 1 is to 16, not 16 is to 1. That is a concept over here. Let us now check the very next problem. That is problem number 6. A volume of 10 power minus 3 meter cube of water is subjected to a pressure of 10 atmospheres. The change in volume is 10 power minus 6 meter cube. The bulk modulus of water is how much? In fact, 1 atmosphere is equal to 1 into 10 to the power 5. That also is called 10 to the power 5 Newton per meter square. Fine. But concept is, in this problem, we have mentioned what is the value of 1 atmosphere. But generally, atmospheric value will not be provided to us. One need to remember that value of 1 atmosphere is 10 power 5 Newton per meter square as such. What is bulk modulus? It is pressure by change in volume by original volume. That is the formula for bulk modulus. In other words, you can rewrite the same. PV by delta V also you can write. What is the pressure that is given here? 10 atmospheres, that is 10 into 10 to the power 5, because each atmosphere is equal to 10 power 5 Newton per meter square, into what is the original volume of the piece that has been given? 10 to the power minus 3 meter cube of water he has given. What is the change in volume that has been given? 10 to the power minus 6. Now you can cut this one minus 3 times. So 10 into 10 to the power 8. In other words, you can write the same as 10 to the power 9 also. What is this 10 to the power 9 here now? Newton per meter square. That should be the corresponding unit, because it is like pressure. So what is the corresponding option over there please? Very first option. But small correction is to be made over there. It should not be simply meter per to the power minus 2. Newton per meter square is the corresponding unit, but 10 power 9 is the corresponding answer for that question number 6. Now let us check the very next problem, that is problem number 7. A metal cube of side length 8 centimeter has its upper surface displaced with respect to the bottom by 0.1 millimeter when a tangential force of 4 into 10 power 9 Newton is applied at the top with the bottom surface fixed. The rigidity modulus of the material of the cube is how much? That is the concept over here. Once again, you need to understand rigidity modulus. That is nothing other than force per unit area by theta. What is that theta? I have already told you. It is a shearing strain. This, in other words, you can write it like this also. I said F by A by displacement by breadth of the body. In other words, you can write F into breadth by area of cross section into displacement. What are the values he has given? You now check carefully. What is the force that is applied? 4 into 10 to the power 9 Newton. No need for you to convert any of the values over here. What is breadth? Breadth means for a cube, length, breadth and height, all the three are same. Each one is equal to 8 centimeter. So we should write 8 into 10 power minus 2 meter. I can write like that. And what about area of cross section of a cube, please? It is L square. 8 square, it will be 64 into 10 to the power minus 4. I now can write into what is going to be the displacement given. It's very clearly mentioned the displacement as 0.1 mm. 0.1 into 10 power minus 6. In fact, minus 3, that of course you can write 0.1 into 10 power minus 3 can even be rewritten as 10 to the power minus 4. That is a better choice always. Okay, now if you look at carefully here, this 8 goes here 8 times. This 4 goes here twice. So what is now left over? 10 power minus 2 cancels 10 power minus 2 times. 9 plus 6, 15. So 0.5 into 10 to the power 15 Newton per meter square will now be the value what we are getting. But check carefully what is the value that has been given there. 10 power 15, here is a point. If you multiply this one by 10, can't you rewrite this one? 5 into 10 to the power 14 Newton per meter square, please. Now we have to change this value according to the given option over there. So what is the correct option for this one? The second option, which is 5 into 10 to the power 14 Newton per meter square. That is the rigidity modulus of that particular metal cube. That is what actually is to be remembered. Now come to the next one, that is question number 8, please. If we look at a metal rod has Poisson's ratio 0.2. If the rod suffers a longitudinal strain of 2 into 10 power minus 3, then the percentage change in its volume is. This type of a question in recent years has been repeatedly given twice at Eamcet level, please. So one should remember this model thoroughly. What is Poisson's ratio? Just now I have told you delta R by R by delta L by L. That is actually the formula. But of course with a negative sign we used to take, I have already told you. This value according to the problem, it is given 0.2. Then what can I write from this one? Delta R by R, that is the fractional variation in radius of cross section of the body. That is now 0.2 into longitudinal strain. What is that value that is given? 2 into 10 power minus 3 it is given there. Now look at this one. This can be written 0.4 into 10 power minus 3. But you have to understand this one is to be taken with a negative sign as such. So this is the value of delta R by R. But our answer is not that. What is the percentage change in volume? In fact, volume is equal to pi r square L. That is the general equation. Delta V by V, when I write like this, you can write 2 times delta R by R plus delta L by L. You know what is delta R by R. You know what is delta L by L. All the values you know. Come on, write that one. 2 into 0.4. It is minus 0.8 into 10 power minus 3. Plus, what is the delta L by L that is given? 2 into 10 power minus 3. So, write 2 into 10 power minus 3. Observe carefully, 10 power minus 3, the multiplication factor is common. Then can't you write 2 minus 0.8? Is it not 1.2 into 10 power minus 3, please? What is its sign now? It's not minus. Minus 0.8 plus 2. It's now going to be plus 1.2 into 10 power minus 3. This must be the correct value. But he is asking you percentage change. That means what you should do? Into 100. Now what will you get out of this one? You will be getting 0.12. Look at the options carefully, please. Plus 0.12 will now be the correct option. That means the very first option is the correct one for this question number 8 as such. Okay. Now let us check the next number, that is problem number 9. Y, K and N represent Young's modulus, bulk modulus and rigidity modulus of a body respectively. If its rigidity modulus is twice the bulk modulus, then what is the relation between the three quantities given? That means what is the correct option that is tallied over there we have to look into. In fact, we know 9 by y is equal to 3 by n plus 1 by k. That is usual formula. But what has been given here, you look at carefully, rigidity modulus is twice the bulk modulus. That means n should be taken as 2k plus 1 by k. Now you can write directly 2k over here. 3 plus 2, which now becomes 5 by 2k is equal to 9 by y. Come on, cross multiply this one. 18k is equal to 9y, that is 5y. 18k is equal to 5y. That is actually the equation. So he is giving you y is equal to how much is the question. So y now will be 18k by 5. Look at that option carefully, please. The fourth option that is being tallied over here, 18k by 5, which is now going to be the correct option for this. Remember this particular relation, all of you. Okay. Now come to the next number, that is problem number 10, please. Look at that. Young's modulus of a material of a rod is 200 gigapascal. First and foremost, giga, 10 to the power 9, that is actually the value you have to remember. Its a coefficient of linear expansion is 15 into 10 power minus 6 per degree centigrade. It is fixed at both the ends and is cooled by 100 degrees centigrade. The thermal stress produced in the rod will be, all of you can understand directly, thermal stress is having a direct formula, y alpha delta t. Y for Young's modulus, alpha for coefficient of linear expansion, delta t for the variation in temperature. What is Young's modulus that has been given? 200 giga, that is 10 power 9, into what is the value of alpha that is given? 15 into 10 power minus 6, into what will be the variation in temperature in this case? It is exactly 100 like. So you can definitely understand 1, 2, 3, 4 zeros. You can cut here minus 2 times. 10 power minus 2 cuts over here 7 times. So 2 into 15, that is 30 into 10 power 7 you are just going to get. Now 30 into 10 power 7, can't you write the same thing this way as 3 into 10 to the power 8 according to the answer that has been given over there, please? So what will be the unit again? Newton per meter square. So what is the thermal stress produced? 3 into 10 power 8 Newton per meter square. That is the corresponding value. Second option is correct option for this problem number 10. Let us now check the next number, that is problem number 11. Young's modulus of a material having cross-sectional area of 1 centimeter square is 2 into 10 power 12 dyne per centimeter square. The force required to double the length of the wire. One should carefully observe this wording, please. Suppose the length of a wire is taken as L. When I double this length, one more L will be added to that. In the sense what I am stretching that one to double its length. Now what will be the present length of this one, please? 2L. And of course we know very well what will be the strain produced when we are doubling the length. Strain is nothing other than elongation by original length. What is elongation here? Small l. What is the original length here? Small l. That means what is it you are getting? Strain is equivalent to 1. Means what? Whenever you are doubling the length of a wire by stretching that, strain value becomes 1, then automatically Young's modulus becomes stress itself. That means what can we write now? F is equal to A into Y. This of course A, area of cross section, it is 1 centimeter square. Then of course if you take F and Y, what will be the value of Y that is given? 2 into 10 power 12. So F will be 2 into 10 power 12 dyne. So what is the correct option over here? You look at second option is going to be the correct option. That means what is to be remembered? Whenever the length is doubled, strain is equal to 1. Length is tripled, strain becomes 2, and so on and so forth. Let us check the problem number 12 now. if the work done in stretching a wire by 1 millimeter is 2 joule, the work necessary for stretching another wire of same material but with double the radius of cross section and half the length by 1 millimeter in joule is how much? That is the concept. All of you should understand whether it is work done or the energy, whatever you call it, half Fx is the formula. F being the force and x being the elongation produced or the compression what has been made over there in the body. But we know very well y is equal to Fl by Ae formula. Therefrom, can't you write F is equal to Aye by L, please? Now let us write that one over here, half into Aye by L into x also is elongation. Therefore, you can ultimately write this particular formula. A for area, Y for Young's modulus, E for elongation and L for the original length. Now, what are the values he has given you? You just look at that one, then finalize the answer. The work necessary for stretching another wire of same material, that means Young's modulus is constant. Forget that. With double the radius of cross section, that means A is a variable, right? And half the length is also a variable by 1 millimeter only. That means 1 millimeter in both the cases is common. That means E square also will be the same. So what can we write now? W1 by W2 is equal to R1 square by R2 square into L2 by L1. That is the formula. What is double the radius of cross section he has given? Therefore, this R1 square by 4R1 square you write. And what about the length there, please? Made half he said. So L1 by 2L1 you write. Cut these two, you are getting 1 by 8. Then what will be the value of W2, please? 8 times W1. What is W1 mentioned in the problem? It is 2. Then automatically 16 joule must now be the corresponding option for us. That means the very first option is going to be the correct answer for this question number 12. Let us check the next number, question 13, please. A uniform metal rod of cross section 2 millimeter square is heated from 0 degrees centigrade to 20 degrees centigrade. Coefficient of linear expansion of the rod is 12 into 10 power minus 6 per degree centigrade. If its Young's modulus of elasticity is 10 power 11 Newton per meter square, energy stored per unit volume of the rod is how much? Just now I have given you energy stored or work done. It is half Fx. What is the other form of that one? Half into stress into strain. That is the other version of this equation. What is this one called actually? Energy per unit volume. That is the equation what actually we are writing. But if you look at carefully in the problem, it is a stress that has been given very clearly with Young's modulus. Therefore, you can write strain as a stress by Young's modulus. So, what can you write now? Stress square divided by Young's modulus you can write here. What are the values you can write? You see, stress means you can write y alpha delta t whole square. That means y square alpha square delta t square. One y gets cancelled. Then what is left over? Y alpha square delta t square by 2. That is the corresponding equation. Now look at the values what have been given there, please. Y is given 10 power 11. Fine. What is alpha given? 12 into 10 power minus 6. That is 144 into 10 power minus 12 into delta t whole square 20 square. It will now be 400 divided by 2. Directly you can cut this one over here 200 times. Now you can check this way, 10 power 11 and one more 0, 10 power minus 12 you can cancel. What is now left over there? 144 into 20. 144 into 2 is 288. So your answer must be 2880. That is going to be the value of energy per unit volume. That of course joule per meter cube. That is the general concept you have to remember. So what is the corresponding option that is correct over here? 2880. The very first option is going to be correct for this question number 13. Look at the next number, that is problem number 14 as such. Look at that one. A wire of length 1 meter fixed at one end has a sphere attached to it at the other end. The sphere is projected horizontally with a velocity of root of 9g. When it describes a vertical circle, ratio of elongations of the wire when the sphere is at the top and at the bottom of the circle respectively. One should understand this is a linked up model with rotatory motion, that too the vertical circular motion as such. Suppose if you take this is the body, which is now hanging over here like this. When you give certain velocity of root 9g, what is its velocity at the highest point? Let us take this way, half mv2 square minus v1 square. That is a change in kinetic energy. That in other words I should call it loss in kinetic energy is equal to gain in potential energy, that is mgh. What is the total length that is given? 1 meter. Therefore this h is to be written as twice the radius. That means this total height becomes diameter over here. M gets cancelled, you can understand. Now you can directly write V2 square minus V1 square is equal to 4rg. That is the concept. But what is r again? 1 meter. Therefore this becomes 4g. Fine. What is the value of V1? This is the value of V2. Here the value is V1 I am writing. So what will be V1 square now? V2 square minus 4g. What is V2 square? 5, that is 9g minus 4g. How much its value will now be? 5g as such. 9g minus 4g. So what will be the velocity at the highest point now? 5g as such. That is V1 square. Then what will be V1? Root 5g. These two are the values you people have to remember. Here the velocity is more, there the velocity is less. What is the question now? Elongation at the highest point by elongation at the lowest point. Means what? You can understand mv square by r minus mg by mv square by r plus mg. This is the equation. Which v to be written here at the highest point means v1. Which v here you have to take at the lowest point means v2. Now come on, just substitute the values over here. What is it you are going to get? You can check it. M gets cancelled. So e1 by e2 is equal to v1 square. How much it will now be? 5g minus g by v2 square. That is now how much? 9g minus g. So directly you can understand here 4g by 8g. So what is going to be the value over here? If you just look at this concept carefully, v1 is to be taken root 5g and v2 is to be taken root 9g. You will be getting this one 5g minus g, 4g over there, no doubt about it. But this one will be 9g plus g, 10g over here. So 2:5 must now be the corresponding ratio there. Look at the very first option which is being tallied with that one. 2:5 is the corresponding value for us. Let us now take the next number, that is problem number 15. The length of an elastic string is A when the tension in it is 4 Newton. And B when the tension in it is 5 Newton. The length of the string when tension is 9 Newton is how much? One of the very commonly asked model at Eamcet examinations in fact. When the force is 4 Newton, its length is A, that is given. What is this value of A means? It is nothing other than original length plus its elongation. Then how much we should write as the elongation at this force please? It is A minus L. That is the equation. Likewise at 5 Newton, what is the corresponding value given? B. That now to be taken as original length plus elongation E2. Then how to write E2 from that one? It is B minus L. Likewise, what is the question that is asked? When it is 9 Newton, let us take this value as X. Then can't you write this one is L plus E3 please? Now you can understand E3 must now be equal to X minus L. That is the concept. Now you can understand whatever be the case, Young's modulus of that material is supposed to be constant. So what is Young's modulus over here? It is FL by AE. That is the formula. Now you can rewrite the same this way. Y is equal to F is 4, L is the original length, A is area of cross section into E1, A minus L. That is equal to, for the second wire, it is 5L by A into B minus L. For the third wire, 9L by A into X minus L. So what you just have to do is, come on, equate these two and come on, equate these two. Just to simplify those two values. Then what is going to be the correct option you people are going to get over there? You check it. Just to take these two, 1 and 2 you take it, 1 and 3 you take it. Simplify the whole lot. You'll be getting 5B minus 4A. That is going to be the corresponding answer for that. That means the simplification I am just leaving for you people. A gets cancelled, L gets cancelled. Cross multiply that one. Second equation you take it. Just to simplify the whole lot, you will be getting exactly 5B minus 4A. This is the corresponding value. That is a corresponding answer for this question number 15. Look at the next number please. That is question number 16 as such. A steel wire is suspended vertically to a rigid support. When loaded with a weight in air, it extends by IA. That is LA. And when the weight is immersed completely in water, the extension reduces to LW. Then the relative density of the material. Every one of us we know the basic equation for relative density please. Relative density is equal to weight in air by weight lost in water. That is the official formula. But we know very well elongation is proportional to force. Force itself in this particular case is weight. Therefore, what can we write now? L in air by L in air minus L in water. Just look at this option directly please. LA by LA minus LW. The second option is going to be the correct option. Problem is looking very lengthy, but the solution is so simple. In one step you directly can get it. That is the concept of 16th problem. Look at the next number, that is problem number 17 as such. The length of a metal wire is L1 when the tension in it is F1. L2 when the tension in it is F2. The natural length of the wire is how much? In fact, this particular question, if you can remember directly, L1 F1, if you just remember that one carefully, L1 F2 minus L2 F1 by F2 minus F1 you can directly take up. The option is the second one, no doubt. But how I will just give you, F1 is going to be the applied force and L1 is the length. That means what you can understand, I have already told you, elongation is equal to L1 minus L. Likewise, F2 the force and L2 is the length. Then elongation can be written as L2 minus L. Now just now I have told you Young's modulus is supposed to be constant there. Then you can write F1 into FL by, that L by A into E, L1 minus L is equal to F2L by A into L2 minus L. Now you can cut this L over here, A over here. Come on, cross multiply this one. F1L2 minus F1L is equal to F2L1 minus F2L. Where from L you directly estimate. What is the formula you are getting here? L1 F2 minus L2 F1 by F2 minus F1. That is the corresponding formula. That means the second option is going to be correct for this question number 17. Look at the next number, that is problem number 18 please. A long rubber string of length 8 meter having density 1.5 into 10 cube kg per meter cube and Young's modulus 5 into 10 power 6 Newton per meter square is suspended from the ceiling of a room. The increase in its length due to its own weight will be how much? In fact, due to its own weight means this is the wire, for example. You know very well elongation is FL by AY. That is the formula. But F is to be taken what? Mg into L by A into Y. What is M here? It is nothing other than base area into length into the value of G into the original length how much the original length to be taken? Length is to be taken with respect to the center of mass. So it should be taken L by 2 by A into Y. A getting cancelled, what is left over? You see carefully here, right? Into rho also will be there, that is the density. L square rho G by 2y. This is the formula. What are the values they have been given over there? You look at length is given 8 meter. So 8 square is 64 into the value of density that is given 1.5 into 10 cube into the value of G that has been mentioned over here as 10 by twice. What is Young's modulus that has been given over here? Look at that value. What is Young's modulus that is given? 5 into 10 to the power 6. Just to simplify this one, you will be getting the elongation produced in this particular case as far as the wire that is concerned. Look at the options now. It now will be 9.6 into 10 to the power minus 2. If you simplify this one, 9.6 into 10 power minus 2 meter, you will be getting exactly the very first option is the correct option for this particular question. Look at the next number, that is problem number 19 now. Look at that one. A tension of 22 Newton is applied to a copper wire of cross-sectional area 0.02 centimeter square. Has Young's modulus 1.1 into 10 power 11 Newton per meter square and Poisson's ratio 0.32. The decrease in cross-sectional area will now be how much? That is the concept. In fact, we all know very well what is he asking for. Area he is asking. In fact, sigma is equal to delta R by R by delta L by L. That is usual way. We all know that one very well. Now what is delta L by L that is given? Young's modulus is given, cross-sectional area is given, then tension also has been given here. Now what can we write from this? Delta R by R is equal to delta L by L into sigma. But in fact we know Y is equal to F by A by delta L by L. Then what to write in place of that one, please? Delta L by L is equal to F by Y into A. You can directly write. Come on, write down the same value here. So F by Y into A into sigma, that is going to be delta R by R. But after getting this one, his question is not that. What is the cross-sectional area? Area is equal to pi r square. That means A is directly proportional to r square, please. So delta A by A is equal to twice delta R by R. That is the concept. What is delta R by R here? 2 into F into sigma by Y into A. Come on, just substitute the values they are given over there. All the values when you substitute, which option that's going to be tallied? Just look at that one. 1.28 into 10 to the power minus 6 centimeter square. That of course is going to be the cross-sectional area. Centimeter square you people will be getting. All the values are given. But remember this methodology. This question has been given in the last year Eamcet paper itself. Remember that one, all of you. Now come to the next one, that is question number 20. Over here, two blocks of masses 1 kg and 2 kg are connected by a metal wire going over a smooth pulley. The breaking stress of the metal is 40 by 3 pi into 10 power 6 Newton per meter square. What should be the minimum radius of the wire used if it should not break given the value of G? In fact, we know when two bodies are attached to the ends of a particular wire taken over a pulley like this, if this is M1 and this is M2, what is going to be the tension in this pulley? First of all, T is equal to 2M1 M2 by M1 plus M2 into G. That is the formula. What is M1 given? It is 1. So twice 1 into 2 by 1 plus 2 into G. How much it will now be? 4 by 3 times G. That is the tension. Now if you take the stress is given to us, what would be the minimum radius he is asking you to calculate? So come on, take the values what have been given to us. Stress is given F by A. That is given how much, please? 40 by 3 pi into 10 to the power how much? that is 6 Newton per meter square. But what is F that is given 4 by 3 G? Now A can be written as F by 40 by 3 pi into 10 to the power 6. This is the value. What is this F now? It is 4G by 3 divided by 40 by 3 pi into 10 to the power 6. After getting this value of A, you just have to calculate that is equal to pi r square, and what is the value of r? You just have to estimate. Exactly you will be getting 1 millimeter for the radius there. Look at that option, exactly the second option. If we just equate them and cancel the things off, r will be exactly 1 millimeter. That is a question number 20 over here. Look at the next number, that is problem number 21. An aluminium and copper wire of same cross-sectional area but having lengths in the ratio 2:3 are joined end to end. This composite wire is hung from a rigid support and a load is suspended from the free end. If the increase in length of the composite wire is 2.51 mm, the increase in lengths of aluminium and copper wires respectively are. Young's moduli are given to us. One thing you should understand directly. Elongation is inversely proportional to Young's modulus. So, elongation of aluminium by elongation of copper, that is equal to Young's modulus of copper by Young's modulus of aluminium. That is our first equation. And second one, elongation of aluminium plus elongation of copper, the total value is put together 2.1 millimeter that has been given. This is your second equation. Look at this case carefully. Y of copper is given how much, please? 12 by 20 you will be getting this value. 12 by 20 means you can write this one 12 by 20, which is now 3 by 5. Come on, cross multiply this one. Y of copper is equal to 3 by 5 times Y of aluminium. Come on, write that one over here, please. You will be getting what exactly this one implies now, please. E of copper, E of aluminium is equal to 3 by 5 times E of copper. Come on, write that value here. 3 by 5 times E of copper, right, plus E of copper is equal to 2.1 mm. Come on, simplify this one. What will you get? 3 by 5 plus 1. It's now going to be 9 by 5. 5 by 9 times you will be getting. That means exactly 1.5 millimeter is the length of copper you will be getting. E of copper is going to be 1.5 millimeter, and obviously E of aluminium is going to be simply 0.6 millimeter, because the total value will be 2.1. So, which is the correct option for us? The very first option is going to be correct for this one. Let us take the last number in this particular order, please. Case number 22, that is the 22nd problem. This also has been one of the Eamcet questions. Simple comparison. Match the following. Hooke's law means it is related to elastic limit. Shearing strain and tangential strain are going to be equal. Bulk strain is 3 times the linear strain, we can understand. So, C stands for the fourth one. Elastic fatigue, that is after effect of elasticity, which of course is a temporary loss of elastic property of a body. Then what is the correct match over here? For A, it is going to be 3. For B, it will be 1. For C, it will now be 4, that is 3 times, right? For D, it is going to be 2. So, what is the correct match over here? The third option is going to be the correct option for this one. Same question has been repeated just in the last 4 years Eamcet paper as such. So, one should understand that these values which we people are talking about here, that of course are the related to elasticity and the nature of elastic properties of a body as such. So, take the concepts carefully and score one question in the final examination. All the best to all of you. In the next class, of course, we shall take up one more lesson like this of physics as such, right? It is okay now.